SKAARHOJ controllers ship with great defaults. In this case, this would be a default configuration. It's something that we set up, configured, described, and we ship the controller with this configuration if you want it. Now, making custom configurations is as simple as pressing the Save Settings button, and suddenly you have a custom configuration, and now you are yourself responsible for changing and adding actions to the various interface components. So how can you figure this out? Well, it's kind of easy if you just click and then you select from this list, but how do you know what hides behind these names, the titles of the various actions you can select? Well, it's all hidden in device cores. So these are like apps you have installed on your controller. We call them device cores, and you find the list right here. And this is dynamically updated over time. See, in the list of device cores, you find links to the manual that describes what these do. So you have a link to the ATEM action manual, to the Kumo router action manual, to Smart Scope manual. Some of them haven't been documented yet, but let's take a look at one of these. So we pick the Kumo action manual. So this links brings us to a PDF file, and in this PDF file you see a description of what each of the actions do. So we have binary triggers, we have pulse inputs, binary outputs, and button colors. So this is the different types of hardware interface components we can link to, and describes how this action applied to a binary trigger will react differently from if it was applied to a pulse input. So what are binary triggers, pulse inputs, binary outputs, and so forth? Well, it's very important to know about the Unisketch manual. And if we take a brief look at this manual, we find some interesting descriptions, like for instance, hardware interface components right here that will explain to us what is meant by binary and pulse generators and analog signals and so forth. So here we actually have this kind of explanation related to how a controller is built. But we can also take a look at a physical controller. So if we just look at this one, we have almost all the types represented. At least we have the most common types. We have buttons, and the buttons can be pressed. They also typically have some kind of feedback. Like in this case, they have a color feedback, red, green, or white. We also have displays, and in this case the displays are connected to the buttons, but that doesn't really matter too much because displays are found also above the encoders here. We also have a display in the corner there, and displays are complex components that will reflect the state of the action that is applied to, in this case, the button associated with it. Okay, so we have buttons, we have encoders or knobs. As we turn these, they are generating pulses. So we can turn them to the right side. They send one pulse each time in this direction, and then they send pulses in the opposite direction. And usually this is used to turn values up and down. Then we have analog absolute components, and these are absolute because when I place the T-bar right here, it stays there. So we have endpoints, and then we have a gliding value spectrum in between the endpoints. So buttons, pulse generators like encoders, and absolute analog components like these, they are very typical hardware interface component types. If we had a GPIO module like this one, it has relays inside, but it also has opto isolated inputs. Then we have another type of hardware interface component. Well, the inputs, if I short one of these inputs to ground, I sort of do the same as pushing a button, and this is why a button is called a binary trigger. So if we look back into the manual for the AJ Kumo, we find that binary triggers is used as the word to describe either a button or a GPI input pin, because from the system Looking at it from the system side, it's the same thing. We have pulse inputs, which are almost always associated with an encoder. But in some cases, like the replay module we also have an encoder wheel associated with a jog shuttle wheel. That's also a pulse input. We have the analog absolute components like the T-bar. That could also be an audio adjustment knob, and these would typically be mapped to stuff like changing a range of values like a transition position and so forth. In the manual here they are not mentioned because for a router it's not possible to assign any of these actions to a T-bar, for instance. So binary outputs are kind of obvious with a GPIO module like this one. So it contains 8 relays, and one relay would be a binary output. The word binary means either or, so there are only 2 ways this could go out. Either the relay is shorted or it's not. And but you can also say that a button color is sort of a binary output, except the fact that we can put a variation to it, like in this case it could be green or red. So binary outputs described here would be if you map a routing an input to an output action to a relay on a GPIO module. It's a binary output that would be on if the input matches the output. In other words, the binary output wouldn't send any action back to the router, but it would reflect the state whether input 1 would actually be shown on output 1 of the Kumo router. And then you see often in the manual that button colors are described. What will happen to the button color? It will be highlighted when so and so. But you also find information about whether it will blink, or if in cycle mode it will be highlighted whenever the button is held down, and so forth. And finally, you will find information about how the displays are used and what information are shown on the displays in case an action is associated with a display. One component I didn't show yet would be a joystick. So a joystick is also an analog component like a T-bar, but we call it a relative analog component, or refer to it as a speed component, because the idea is with a joystick that it falls back into a center position, and the further you take it away from the center position, the higher the speed in a more abstract sense should be. Of course, a joystick for a robotic camera would be pan and tilt, but you can actually think about it as adjusting the speed in a certain direction. And if you associated a joystick with any other parameter, like actually also a transition position or iris adjustment, then it would be a matter of how quickly that value was changing.